Let's do an example of taking the first and the second partial derivatives. This is usually the function I like to start out with because it has slightly non-trivial first and second partial derivatives. If I want the partial derivative with respect to x, I have to use the product rule. So it's the derivative of the first times the second plus the derivative of the second, but y is constant. So this is going to be xy e to the xy like that. Let's see here. I'm going to have lots of columns here. Fy, let's see here. X is now a coefficient, so we're just going to get x squared e to the xy. And those are the two easy ones, right? The two partials with respect, the partial with respect to x and the partial with respect to y. If I want to find fxx, I now have to take the partial derivative of that with respect to x. Let's see here. I'm going to get y e to the xy like that. That takes care of this part here. The other one I have to use the product rule on, so it's the derivative of the first, which is y e to the xy, plus the derivative of the second. The derivative of the second is e to the xy times the derivative. That's going to be another y. So that's going to be x squared y e to the xy. We can simplify a little bit, although we don't have to. How about 2y e to the xy plus x squared y e to the xy? That's fx. Fxy. We have to do this again. Now taking the derivative of this thing up here with respect to y. The derivative of the first is just going to be x times e to the xy. To take the derivative of the second, I have to use the product rule again, so it's going to be the derivative of the first, which is going to be x e to the xy, plus, let's see, it's the derivative of the first times the second plus the derivative of the second. Well, y is now the variable, so that's going to be, an x was going to pop out. We're going to get x squared y e to the xy like that. Move this up a little bit. We don't have to simplify, but we will. I'm going to get 2 e to the xy plus x squared y e to the xy. Whew. All right, now I want fyx. So I want to take the derivative of this thing up here. I have to use the product rule again because I see two functions of x there. So that's going to be the derivative of the first. That's 2x times the second. That's e to the xy. Plus the derivative of the second, where x is the variable. So that's going to be x squared y e to the xy, like that. Now, by the way, you're going to see that fxy here is equal to fyx. That's not guaranteed to happen, but it does happen most of the time. Fyy. Let's see here. The x squared is now just a coefficient. Happy about that. Times the derivative of e to the xy with respect to y. The derivative of xy with respect to y is just x. See what I'm going to get here? Let's write it like this. So the coefficient goes along for the ride. The derivative of e to the blob is e to the blob times the derivative of the blob. And we're going to get x cubed e to the xy like that. And we have our 4 second partial derivatives. Oh boy.